Hey there, math fans. What are Taylor series? What are they all about? Why are we doing this weird stuff? What's wrong with you, Dr. Lovelace? These are the questions I get all the time when I'm teaching Calculus 3. I taught Calculus 2 last term, and several of my students came to me and said, we're in Calculus 3 now, and would you please tell us why these matter to someone? They're very odd. Right there, you can see a visual of the first several Taylor polynomials for the cosine function. You can see how it hugs the graph, but who cares, right? There's a ton of really interesting applications. If you stick around in math or go on engineering, you're going to use these all the time, but I don't like to really sell students on these things. I mean, I just think they're beautiful in and of themselves. But I do think I'll start making a few videos. Let me know if this is interesting to people, because I did because a couple students came to me and was asking this. I was like, well, what do you find when you search online? And I was sort of appalled in some way to find that when you search for Taylor series applications, you find at the top of the list my review sheet from many years ago that I made. I was appalled because I make $0 from that. And I had recently had a tenure track colleague tell me that I was replaceable. I don't matter. This is not funny, but I think it appears people want to hear what I have to say, so I will do this. And if it's interesting to you, I will continue to do it. I do think this matters. I want you to be interested in this material. Here's what you're going to see. So I'm going to go through this old review sheet. I've made a video for it a long time ago, but it was before I could make better videos. You might say, this is better. Okay. Anyways, I'm going to talk about the bell curve. Some of these applications I don't know if I find as interesting anymore, but I'm going to talk about them. So I'll do one on the bell curve if that's interesting. I already have this in this worksheet you can find, which apparently a lot of people have been using. I'll talk about how you can take Einstein's theory, and I am no expert on that at all, but I can understand the idea of taking a theory a formula that is known, approximate the Taylor series, and say, hey, look, that's Newton's theory, which gives us a deeper understanding of what's going on. It's used to solve differential equations. I remember well, I was taking a course in upper level differential equations and I forgot how to do the problem and I solved it with Taylor series instead, which is a lovely little story I can share. One thing I didn't have in this was this thing called perturbation theory, which I would lump in with asymptotic behavior. I had an office mate who studied how certain chemicals in the brain behave, and they wanted to show that if you perturb the chemicals a little bit, that it still entered stable behavior, and he used Taylor series as his primary function. And really this all goes back to the history of what is a function, and that math started really with the study of polynomials in some way. And this idea of Taylor series is, how do we think of everything as a polynomial? And how do we make sense of that? Now, my favorite application is combinatorics. Most people watching this video, that won't be their favorite application. This is extremely valuable. In fact, I recently used it to prove kind of an interesting fact about counting things in cribbage. You can watch that video. Anyways. And then the other thing is just beautiful relationships. Now, the moment I say beautiful, a lot of my students turn off the video. You say, well, we already turned it off. Nobody's watching. All right, I'm used to that. But I will say a couple of things, show you a couple of things, and then I'll stop this. This is just an intro. And then give me your support, likes, subscribe. Let me know this is helpful. Let me know which one of those sounds the most interesting to you, and I'll give it a little more energy. Again, I'm not trying to sell you on anything. These are just interesting things that happen to overlap with Taylor series. I'm sort of done convincing people that math matters. It matters to you or it doesn't. But the thinking, problem solving, I think matters to everyone. But again, I'm not going to sell anyone. I'm done convincing people of what they should learn. Learn what you want to learn. I just hope that everyone embraces learning in some way. And I hope there's something interesting here for you. Okay, so before we go, this is the Taylor series for cosine. Part of the reason that students lose interest in Taylor series is because of how we teach it. We often teach it with these error bounds. Now, error bounds are really important, but if I show you this error bound, I can quickly convince you and talk about that it does converge. But to make that precise, so there's the error, the gap between the functions, you can see that it's getting smaller and smaller. There's the cosine one. Oh, this is a random other function. There's some practical things, like if you have a complicated function, you want to find that root there. What could you do? Well, you could find the Taylor polynomial nearby and then find when the line intersects. That's fairly easy too. And you say, well, what if that's not accurate enough? Well, then you use the second Taylor polynomial. That's a quadratic. We can solve when a quadratic equals 0. And boy, that's going to give us a really close answer. You can't even tell the difference. I don't know if that application is interesting. A lot of times the applications we use is, you can use it to approximate the value of something. Students are like, I don't care about that. We have a calculator. I get what you're saying. This is the geometric series. We use this all the time. It's used in like so many formulas. I use it in my business math class for the mortgage formula. Things related to this happen all the time. You've probably even heard this before. If someone goes for a walk and they step 1 unit and then they go half a unit, that'll be at 1.5, and then they go half of that again, and then half of that again, and half of that again, and half of that again. They get closer and closer to 2. This approaches 2. Some students are amazed by that. Some think mathematicians, you're weird. But that's one thing you can get from the geometric series. That's this series. Now, this series has some problems because there's an asymptote there, but let's let it go and see. The error does get smaller, but it seems to be afraid to get close past -1. I really like this visual because you can see that because of the asymptote at +1, something weird happens at -1. But this is an extremely valuable approximation, comes up in so many things. Here's the sine one if you want to see another one. This one's really cool. Again, it just hugs the graph no matter how far out you go. It keeps getting closer and closer. Oops, I didn't go far enough. We'll go a little further. It gets close. Whoa! That's fun. Mostly, I think engineering programs, sciences just want you to know that you can represent sine and cosine in either the x and y. That's probably the main reason they want you to see it in our courses. But again, we don't get to teach you some of the fun stuff. We just have to show you the boring pieces of it and show you how to find error bounds. And then we get to hand you off to the other subjects where they get to do the fun stuff with you. Here we go for e to the x. E to the x is kind of cool because it flops back and forth. Oh, I shot it back to the beginning. So if those things are interesting to you, to me, it's really all about this first one. Really, the first calculus books started with Taylor series and defined everything from Taylor series. Why did they do that? Well, because you started with lines and parabolas and cubics, and then you just kept going. And from that, you got these other functions. That was a lot more motivated for even like where e to the x and sine come from. Then later, those functions became so common that they lost their connection to Taylor series, and now we have to teach you the connection to Taylor series. So Taylor series and this idea of polynomials is at the heart of our study of functions. So I'll say a little bit about that in the history. Again, I'll do the approximation stuff. But it is just in the fabric of mathematics. So sometimes it's one of these questions of like, why do we care about something that's just in everything we do? You don't have to care about anything. But I hope to make it somewhat interesting to you. If you find this interesting, you know, like I said, give me a like or subscribe, or just tell me in the comments more than that. Because I don't care about the subscribers, the like and subscribe. I just would like to get some feedback on what students would find useful. I'm trying to bring joy to learning our entry-level math courses. You don't have to do the fun stuff later. You can do it now. So I would like to know which parts of this would bring you joy or excitement, and letting me know in the comments would be helpful. All right, thanks.